This video is going to explain how to load a robot into Onshape and put it together into an assembly file with properly mated joints. To get started with Onshape, first just go to onshape.com. It brings you to this page, and then if you are a student, you can do the create a student account up here. So click that and create your student account here using your school email address. If you need to renew your student plan, then you can renew it here if you already have one. Now I already have an account, so I'm going to log in. Basically, what you want to do is to create your first document. You go up here on the top left to create, and then document. So you can call the document whatever you want. I'll call it a robot. You would want to name it after whatever is the name of the robot that you're going to load in, but for now, it's always possible to rename. That's one of the benefits of Onshape is that you can rename your files and it still knows what they are, even if you've used them in other documents. So we'll just call that robot for now and create. So it brings us into here. So to import CAD files, you click this plus button and we'll say import here. Then navigate to wherever on your desktop or your computer that you have stored that. So normally it would be in downloads. If it's a zip folder, make sure that you unzip the files and then go into those unzipped files and you can just highlight all of them and click open. Import to this document, import appearances. That's fine. Imported models with y-axis up would be if you are importing a SolidWorks file in particular, and then creating a composite part when importing multiple or non-solid bodies. That would be if you just have surfaces, but in this case for the robot, we don't want to create a composite part of the multiple robot parts because that would lock it all as one piece and then you wouldn't be able to move it. So we'll just go with import appearances, click import, and it will take a few minutes for everything to upload. So you'll know when everything's uploaded because it will say the name of the part and then was translated successfully. We'll X out of that. And this is the IRB 7600 robot. So this is what the robot looks like. The particular model that I brought in was the 3.25 kilogram, 3.1 meter reach, and I used the step file. You can also use a parasolid. This was gone into more details in the previous video, but just to kind of give you an overview, it's that. You go down to more information, and then if you click on the data sheet here, that brings up this file, which tells just a little bit more about the robot, the axis ranges, the different models that there could be, and max speeds and just, other stuff like that. So it's the data sheet for all the 7600 family, and ours is this one here. So we can rename our robot. So that's 7600, 325, 3.10. You can see all the parts showed up here on the bottom. So we'll click on, see these different ones, working area, and they'll all go here. And then there's a new folder called CAD imports, which just has all of the individual actual files that are not the translated version. So to get out of that, just click the Alt Tabs button again. Brings you back here. So Part Studio 1 has nothing in it. We don't really need that, so we can delete it. And then this takes us to our next part. So one of the things that we'd want to do here is go through and actually rename these files because right now they all look the same. You can see that the whole name doesn't fit. So we'll want to rename that so that everything's called what it actually is. So this is the workspace. This is just an illustration of what the robot can touch. So we'll rename that and call it workspace. It's also just sort of like a bubble, say bubble. Now for this one in particular, we might want to change the color of it. So we'll right click, edit appearance, and we can make it transparent, change part transparency. So this way we can actually see what's inside of it. So let's just put that to 50%. Okay, so moving on, let's see. Okay, so this one's link 4. So I'll just go through and rename all of these. So right click, rename link 4. And then you'll see in here, there are actually 5 different things. And we just want this to be one link. So if we go through and click, that is the actual link. This is some little part on the top. This is the ABB logo from the other side. This is another little part, and this is another ABB logo. So this one, it was the main one, and that's the one that we'll rename as link 4. Okay, so now link 3, right click, rename link 3, and then on the parts again, right click, rename link 3. And you want to just go through and do that for all of the parts. Okay, so we renamed all of those. Now the piston and the cylinder are parts that don't have an actual link number because not all robots even have them. But this particular robot has a piston and a cylinder just because it's so heavy that it sort of needs that to help its joint to help out the motor at joint 2. Okay, so now that we have all of these parts, you'll notice in some of them that there's this sort of like little front, top, and right planes. And the part is not necessarily at the origin. And that's okay because actually what is happening with this part is it shows up here the distance away from the origin that it will be in the assembly. So if we go through and click here, so link 5 is up at the top, and just to give you an idea, so we'll just click on that and rename it like that. Okay, so now we need to take all of these parts and put them into an assembly. So click on the assembly tab. We'll rename it and just say robot. And then we go to insert, part studios. All of the parts show up here. So we can just click on every part. So click on each part without moving your mouse away from this little window. And you'll see that the parts are all showing up in the right place. So we did that, and then piston. Now we don't really need the workspace, so I'm not gonna, well, I guess I can bring that in and show you how that works. So then we'll click the check mark. Okay, so all of the parts are in here. I'm gonna zoom out. All right, so this bubble, we don't necessarily need it, but we do want it to stay in that location. This bubble explains all the places that the robot can reach. So the robot can basically reach anywhere between the outer bubble and the inner bubbles. It's programmed not to go into the inner bubble so that it won't collide with itself. So we'll just take this bubble and right click, fix, which means that it can't move, and then right click, hide, and it disappears. Okay, so it's still there, we just can't see it. So the robot looks right, but what can happen if we actually try to move it, let's say we just click on it and try to move it, it falls apart. So we'll undo that. We need to mate all of the parts together with revolute mates at each joint. This will allow the robot to move like it normally would. So step one is to mate all of the joints together. And then step two will be to set joint limits so that the robot behaves the same way that the datasheet says it should behave. So we'll go through and do the mates. We want to mate from the bottom up to the top. That will prevent the other parts from moving around while we're working on this one. So if we first want to mate the base, we see the base here. Now we also see over here all of the links came in as expected, and the extra junk that was in there with link 4, we don't really need that here because it doesn't help tell us how far the robot can reach. And the main thing with loading the robot in is that we want to see if it can touch all of the places in its cell that we need it to touch. So we'll just get rid of those. Now, the cylinder and the piston, those are also not essential. So if you're doing this for the class assignment, you do not need to include the cylinder and the piston because again, those really are not essential to the distances that the robot can touch. That is really just supporting, it is not a separate actuator. So I will show you how to put those in later, but for now, let's just hide that and right click, hide that. Okay, so for your class assignment, this is all you would need as far as what you see. Now, we actually do need to mate all of those parts together. So the first thing we want to do is fasten the base to the origin. So that one will be a fasten mate. Now, if you click fasten mate, then we need to click on the mate connectors. So if we click on the bottom here, we can see that it doesn't really go in the center. That's bad. It just clicks on the center of mass. So we need to add a mate connector on the base that will allow us to mate it to the actual origin. So I'll X out of that fasten mate. And then we'll go to the base, which these are actually kind of not in a great order. So you can just drag these around to put them in a good order. Okay, so base, we'll go here. We need to add a mate connector to the base. So adding a mate connector, go to this button, scroll down until you see mate connector, and then click where you want it. So we want it on the origin, and the owner entity here is base. So it's on the origin, but it is connected to the part. So it will import into the assembly along with the part. We'll just click check. And we'll go back to our robot, and you can see there it is, it showed up. So now what we need to do is do the fasten mate. Click, it says mate connector of base 1, so that's good. And we'll just also click the origin. Well, that didn't really work. We can kind of drag this away and then click the origin. And then it pops to the right spot. Let's just make sure that that does not look right. It is upside down. So we flip it. Flip primary axis. Actually, that doesn't look right either. Let's just undo that. We click X. Okay, it goes away. So fasten mate again. We will get the mate connector of base 1. Move that out the way. Click the origin. Okay, that looks much better. And we will call this ground. So now we have the ground. Okay, it says fasten to origin even though assembly has fixed parts hidden. That's fine, I think. Okay, that's just the the bubble. We can even delete that bubble. We don't really need it. Okay, so that made the error go away. All right, so next we need to do each of the joints, starting with joint 1 and going to joint 6. So the joints will be a revolute mate. So here's the revolute mate button. We'll click on the revolute mate and we need to find the mate connectors. So we'll drag link 1 out the way. We need to mate base to link 1. Just click in the center and it should automatically find the mate connectors. Okay, looks good. Rename it as J1. Check. Now joint 2 should be around this joint. So, okay, looking at that, joint 2 goes through here. So we'll take a revolute mate and then we will drag that out the way. Click link 1 and then click the side of link 2 that matches to it. Okay, that popped into place correctly. So we'll call that J2. Click the check mark. So when you click that check mark down there in that box, it automatically opens up a new one. So we need joint 3 now, which will be this one up here at the top. So let's move that out the way. Okay, so we need here and center of the circle here. Call that J3. And then the next one is link 4. So look, when I highlight link 4, you can see that it actually goes all the way to the back. But this part here is where there's going to be a separation. So I'm going to go over to the top. You can see when I move that, it was actually all the way in the back. So when we do our revolute mate, we'll revolute mate this ring because this is what was actually connected to link 3 here. Call that J4. And now we need J5. Okay, move that out of the way. Joint 5 is going to go through between those two. So we will put the revolute mate. Like that. Like that. Call this J5. And then finally we have joint 6, which is the wrist. So we'll pull the wrist off. Sometimes it takes a little to actually drag it around. Okay, we drag that off, but that wasn't the spot we wanted, so we'll X that. Click this. Click that. And now we have J6. Okay, so we have all 6 joints. So now we can kind of move it around, see, okay, that spins fine. This moves back and forth. That spins. Let's just undo, get the robot back to where it was. Sometimes you get the robot into like some crazy weird position. In order to always go back to where you were before, we need to make a home position. So home position is when all joint angles are 0. To make that, go over to named positions. Click add named position. Click in here where it says name position 1 and type home. And then enter. Click this done here in the yellow box. Okay. So now if we say we get the robot into some extremely bizarre position, you know, how do we get out of this? Well, We go back to name positions, click home, right click, apply name position. Now it goes back to normal, and we can click the name positions again, and that just sort of wraps up that sidebar. So now the robot is moving correctly, but we need to make sure that all of the joints are actually within limits. So even though in our model, we could swing the robot all the way around like that, the robot can't do that in real life. It would collide with itself. So we need to put in the appropriate limits as seen in the datasheet. So here is the datasheet that we had downloaded. We can, if we want, actually import that datasheet into our file. So we'll just go to downloads, select the datasheet, and open that. So that will bring in the datasheet so that we always have it to look at if we need. But looking at the datasheet here, we need to find the movement. Okay, so movement here. And I'll zoom in on that so we can see it a little better. Okay, so working range, axis 1, plus and minus 180. So we'll go here. Joint 1 has limits of plus and minus 180. So we right click, edit, and click limits. So minimum minus 180, these are all in degrees. Maximum 180. We can click this play button to see, okay, so that spins around, great. And click that. So now the second joint, plus 85 to minus 60. So the robot can go, if we look at which way is plus and which way is minus, that's a critical. So the robot can go forward, moving, it could go like that, or it could go backward, moving like that. Okay. You can actually click on it and then kind of rotate it like that. That's easier sometimes. So it can go back there, it can go forward there. So let's see in the data sheet, plus 85 to minus 60, what even direction should each of those be? So here, so we go to J2, right click, edit, limits, and we will say negative 60, and then positive 85, and let's see if that moves like we think it will. Just press the play button. Well, that was really not what we wanted to do. We can switch these, reorder items, and now we'll play it again. Okay, that didn't help. We'll just click the check mark and see how it can move. So click that. Try and move this. Okay, that's as far as it goes down that way, and then we'll move it back here. So that seems like it went backwards 60. If this is 0, that looks about 60 degrees. This looks about 85 degrees. So this is probably correct. Okay. So now joint 3. Positive 60 to negative 180. Okay, so joint 3, it looks like could probably go down 60 and then back 180. Yeah. Okay, so that must be positive here, must be clockwise. It must be, the axis must point into the page. So we'll right click, edit, limits, and we'll just say 60. And, oh wait, no. So that would be negative 180. And then 60. And check. Still doesn't tell us. We'll right click and fix that. So now that one's fixed, that one can't move. So now we can go rotate this. That looks like we probably put the 60 and the 180 in the wrong place. So, because that won't go anymore. So we will edit minus 60 and then plus 180. Okay, let's just hope that's right. Okay, there we go. Now link 2 is, we had it fixed, so we'll just unfix that. And then back to home, right click, apply name position. Okay, it's fixed again. And now J4. Look at J4. Okay, that's plus and minus 300. So that one doesn't matter which one's really the positive, which one's the negative. So edit, limits, negative 300, positive 300. All right, so now joint 5. Okay, plus and minus 100. So we'll go back here, right click, edit, limits, minus 100 and 100. Okay, looks about right. And then finally joint 6. Okay, so plus and minus 360, maximum revolutions, plus 67 and negative 67. So that's pretty huge, but we'll just put in the plus minus 360. So right click, edit, limits, minus 360 and 360. All right, so now we have all of the limits set. So this robot is ready to import into a document. So the next video will explain how to import that robot into an assembly and check if it can reach all of the right positions. So here I have color coded all of the pieces just to make it easier for you to see. So we have the base is gray, link 1 is red, link 2 is orange, link 3 is yellow, link 4 is green, link 5 is blue, that's a little hard to see, so I'll go over the top, and link 6 is purple. So one thing I didn't tell you how to do earlier was how to put in that cylinder. So we have the cylinder, we'll just show this now, right click and show, and the piston, right click and show. So if we want to actually mate those in, because right now if we move the robot, which one easy way to do it is if you click on the wrist, then you can actually make it move in certain directions like that. So you want the end of the robot to be in a certain place. So you can see that the robot is moving around, but the piston and its cylinder are actually not. Okay, so we need to fix that. Do the mates that we need. So let's make a revolute mate between the piston and zoom in on this link 2 there. And we'll call that JP2 because it's the piston. Okay, so let's look at that from the top and just make sure that's lined up properly. I think that looks a little weird. Oh, okay, so this cylinder should also be matched up to link 1. So let's see, let's put this back at 0. Double click 0, enter. Okay, and looking from the top. All right, so that seems about, actually it seems a little bit low compared, like it's not quite lined up. Let's see if this works. Click this. Let's just move it out the way a little bit. We can see, okay. So there probably should be a revolute mate connecting those little tabs into the centers of these. So let's just say revolute mate between Let's get that surface and that surface. See if that works. Look at it from above. Is that properly aligned? It looks like that is too far. So X out the one on the cylinder. We probably want, maybe we want that part of it. Look at that from the top. Is that lined up? That is probably close enough. Looks like it should. No, there's definitely a gap there, but let's see how big that gap is, and then we'll know how far apart these need to be. So if we click those, show measure details down here in the bottom right corner, and that is Y direction. Okay, negative 13.98. So probably we need to move it about 7 millimeters. So we'll go back here to, it was just Revolute 1. So we'll double click that, offset, and we need a 7 millimeter offset to center that. So the Z offset would be 7 millimeters. Enter. Okay, that shifted the wrong way, so we'll go minus 7 millimeters. Okay, so that looks centered now. And we'll call this cylinder. Okay, but somehow the piston is not in the cylinder. So we need probably to do a cylindrical mate. And we will slider mate. So that's good. So this one, okay, cylindrical mate here. It can rotate and it can slide. So we'll click that, and then we will just mate. It doesn't really matter anywhere on here. We can mate to that. And let's call this piston and cylinder. So now, let's see if that worked. No, it didn't, but there was this one. We just need to delete that here where the cylinder connected. Delete that, and I bet that'll make everything. Okay, everything looks fine there. But this needs to be slid further back. The top. Okay, and then it needs to be centered there. So we can see that there's actually, it almost looks like there's a little interference there. Probably the parts just are not made exactly. So, because normally, so this cylinder would realistically need to have a hole through the middle of it, or this piston connection, so that it could actually mate onto here. We just did the JP2, and instead of making that a revolute, we'll make it a cylindrical so that it can just shift linearly a little bit over. There, everything turned black. Now it's nice. Okay, so now we have the robot there. Let's just make sure we can, let's grab the wrist and make sure we can move it around. Okay, good, it moves. Okay, that looks good. So now we can put it into an assembly and make sure that it can touch all the places we want it to touch. Before we do that, we need to save the document. And before we save it, we want to make sure it goes back to its home position. So apply name position. And now, just because we did those cylinders anyway, we'll just update name position. Now it's got to save with the cylindrical mates. And then we need to create a document version. So to do that, we can click here, create version over here in the top left. Create version and V1, create. So a version has to be created before you can use your robot in another document. So the next video will explain using the robot to reach around the cell to do a reach analysis.